question number 6. What is this question all about? A particle moves in a straight line, starts from rest at a fixed point O on the line. Let me highlight this particular statement. There is a reason for that. What else does it say? Its velocity equation is given as such and such. So it's a kinematics question, and this kinematics is related to differentiation and integration. Secondly, why have I underlined this particular sentence? Because the question says it starts from rest and from a fixed point O on the line. Initially, the velocity is 0 and the displacement is also 0. So maybe if the need arises, I can use this particular piece of info. First of all, part 1, find the displacement of the particle when t is equals to 1. So part A, what I can do is that displacement during the first 1 second, basically that is what they are asking. That is 0 to 1, t square minus 8t 3 over 2 plus 10t dt. Now when I integrate it, this is just like p1, t cube over 3, 8 as it is, t raised to power of 5 over 2 division by 5 over 2. This is 10t square divided by 2 plus a constant of integration c. Sorry, there won't be any constant of integration because we are plugging in the limits 0 and 1. We will evaluate this and we will get our answer. Is there an alternative method? The answer is yes. What's the alternative method? Which if someone wants to use it, that is find displacement equation if the examiner asks for it or if you are in the mood of getting it. That is the same thing, integrate dt. You will get the same thing, t cube over 3 minus 8 t 5 over 2 division by 5 over 2 plus 10t square over 2 plus a constant of integration c. Now plug in that particular condition. What is that condition? When t is 0, v is 0, s is 0. So when you evaluate s is 0, when you plug it in, this is 0, this is 0, this is 0, this is 0. Therefore, in the end, what will happen? C will come out to be 0. So now you have the displacement equation. And this is like this. I've simplified it a bit. And now plug in t equals to 1. So this would be the value of that displacement in meters. So there were two approaches for this one. The usual approach with the limits and the other one with the displacement equation. Let's move on. Show that the minimum velocity of the particle is this much. Now 7-mark question on this. What do you think is the logic behind it? What do you need to show? First of all, anything. If you want to talk about minimum or maximum of anything, basically the concept of turning point, derivative of that thing should be equal to 0. What does it mean? If I ask you about minimum or maximum displacement, that means derivative of displacement, which is velocity, equals to 0. If I talk about minimum maximum velocity, then derivative of velocity should be equal to 0. If I talk about minimum or maximum acceleration, therefore differentiation of that acceleration should equal to 0. Remember this logic. Now let me put this logic on the side. Now usually Let's not talk about it, the mystery part of this particular question. Let me first show you the working. The equation is t square minus 8t 1.5 10t. T square minus 8t 1.5, that's the power, plus 10t. Differentiated dv by dt, that is 2t minus 8, 3 over 2 comes down, t raised to power of half, and 10t becomes 10. Simplified further, that is 2t minus 2 4s are and 4 3s are 12 minus 12 t raised to power of half plus 10. I can even write this thing as 2t minus 12 square root t plus 10. This is my dv by dt. Now dv by dt should equal to 0. Therefore, 2t minus 12 root t plus 10 equals to 0. Divide by 2. T minus 6 root t plus 10 equals to 0. So now you are back to P1. And this is a disguised quadratic equation. And you will make a substitution. Let m equals to square root of t. Therefore, m square is equals to t. So what does it become? M square minus 6m plus 10. Actually, 10 becomes 5. So let me do the correction. And you come across these mistakes, especially when you're teaching it and solving it live. So this is 5, this is 5, and this is 5. So m square minus m minus 5m plus 5 equals to 0. M minus 1 minus 5 m minus 1 equals to 0. Therefore, m minus 1, m minus 5 equals to 0. Therefore, m comes out to be 1 and m comes out to be 5. But we are not solving for m, but m is square root of t. So therefore, square root of t is 1, square root of t is 5. Therefore, t is squaring it, that is 1, t is squaring it, which is 25. Now here is the mystery part, which is which value do I choose and which value should I reject and what is the rationale behind it. So now again P1 knowledge comes into action. That is the concept of the nature of turning point. So nature of turning point. That is the second derivative test. That means if the second derivative is positive, it's a minimum. If the second derivative is negative, it's a maximum. And if it's 0, it's neither a max nor a min. We won't be having issues with that. So now this is your dv by dt. That is acceleration. And let's calculate the second derivative. So dv by dt, the unrationalized form, that is, you can also take common out, that's not a big deal. That is 2t minus 12t half plus 10. 2t minus 12t half plus 10. So the second derivative, d square v divided by dt square, that is 2 minus 12 into half into t into negative half, and derivative of 10 is 0. So therefore, this is 2 minus 6 t raised to power of minus half. This is 2 minus 6 over square root of t. When t is 1, let me plug this value. When t is 1, the second derivative is 2 minus 6 over root of 1. This is negative. Correct? When t is 25, v double prime is 2 minus 6 over root 25, which is 6 over 5. Let me just double check one thing. This is 12 comes down and this becomes 6 and this is root t, and there was a minus sign in the beginning. Yes, there was a minus sign. So now t comes out to be 1, t comes out to be 5. The first value is giving me a negative answer. The second value is giving me a positive answer. Therefore, this is a max, this is a min, and what are they asking about? They are asking about the minimum velocity. So reject this value, accept this value, and last but not the least, the very last part of this particular question is that how much is that value? Show that the minimum velocity is this much. So therefore, plug in, so let me write it properly, plug in t is equals to 25 in velocity equation. So therefore, the velocity equation is the original one, t square minus 8t. Velocity is t square minus 8t raised to power of 3 over 2 plus 10t. Is this the one? Yeah. So therefore, this is 25 square minus 8, 25 raised to power of 3 over 2 plus 10 multiplied by 25. Use a calculator and you will get your desired answer. So that's quite easily done for 7 marks. So this was question number 6, which required a complete knowledge of pure maths. Let's look at question number 7, and it seems that this is the last question for this one. Yes. Now question number 7 says, two particles P and Q of masses such and such are attached to the ends of a light and extensible string, passes over a fixed smooth pulley attached to the top, that's a pulley. This is particle P, this is particle Q. This is 0.5, this is M. The angles are given. The string is taut. The particles move on the line of greatest slope. They move along this, they move along this. A force of magnitude 0.8 Newton, that is extra, causing P to move down the plane. This first paragraph is for everything. It is given that PM is 0.3 and the plane on which Q rests is smooth. So this plane was already smooth. This P is on a smooth plane. So let me underline this. This P was already on a smooth plane. Nothing was written about Q. And in the first part, they say Q is smooth. Find the tension in the string for 5 marks. Now, let me label some forces. This is one force. And what else is there? There is a tension over here. There is a tension over here. Then there is this particular force down this plane. And what else should be there? I think that's all about it. So therefore, this is M. This is 0.5 G sine of 30 degrees. This is tension. This is going down. And this one tension is here. And this is mg sine of 45. The component down the plane is sine. We don't need the cos component. We don't need r because it's all smooth, nothing to do with friction. This particular particle is going up. So let's write down the equation. 0.5 g sine 30 plus 0.8 minus tension is equals to 0.5a. Tension minus 0.5g minus mg sine 45 is equals to ma. Is there anything else? No, there is nothing else. When I add these two equations, what do I get? I get 0.5 g sine 30 plus 0.8 minus mg sine 45 is equals to 0.5 plus m multiplied by a. Now, they have given m. So in this scenario, the value of m is given. So this is 0.3, this is 0.3, this is 0.3, this is 0.3. And since this is the only unknown, first you will find the value of a, then use any equation, and you will find the value of t. So that is the working for this part, and that is straightforward working, nothing special in this one. Now, this part, let's read it I might be needing the diagram. So let me just erase this thing, but that would take a lot of time. So let me first, let me erase this. So I'll be needing the diagram. Okay, this is all good and all clear. Take screenshot and save image. And this is perfectly fine. Let me use this image over here. Okay. Now, what does it say? It is given instead that the plane on which Q rests is rough. So now Q is rough. What do I need over here? First of all, label this thing. That thing is just like before. So now let me rotate my table a bit so I can write it properly like this. And I need R in this scenario. I need the weight component in this scenario. I need the tension in this scenario. That tension should also be there. What else is there? There is this particular weight component because that point is smooth. And I think that's about it. So let me label all the things first. So now when I go to the labeling part, this is 0.5 G sine 30. I don't need R in this plane. This is tension. This is tension. This is R. This is M G cosine 45. This time M is unknown. And this is mg sine 45. And one other thing. Because this one is going down, this one is going up, that means there should be a frictional force also. And that frictional force is this thing that is going down like this. So that is the frictional force that I need, F max. But the question says, I might be needing it, I might not be. Use an energy method to find the value of M. So there are different options of working for this particular part. What I'll do is that, first of all, let me do the calculation for the tension because everything is there, and in this scenario, they both have moved a distance of 1 meter. The speed is 0.6 meter per second. Okay, now first thing, there's some information given. Let me evaluate this thing. Why is it becoming a curve? No idea. So first of all, I can apply kinematics. I can say U is equals to 0. V is equals to 0.6. Distance is 1 meter. And I can find V square is equals to U square plus 2AS. V square is equals to U square plus 2AS. So therefore 0.6 square is equals to 0 square plus 2 into A into S is 1.0 meter. Therefore A comes out to be 0.6 into 0.6 divided by 2. That comes out to be 0.18 meter per second square. That is the answer for this particular part. Now, if I focus on particle P, so now the next thing is focus on particle P. So this, you can label the steps. This is step 1. And this one is step 2. That is focusing on particle P. If I focus on particle P, this is 0.5 G sine 30 plus 0.8 minus tension is equals to mass into acceleration, which is 0.18, which is found from this first part. So that is this thing. So now let me grab my calculator. Let me do some calculation. And 0.5 into 10 into sine 30 plus 0.8. This is answer, and then subtracting this thing. So therefore tension comes out to be 3.21 Newton. That is the answer for the second part. So this is the second part that you get, tension. What is the third part? The third part is that concept of, let me write it shortly, step 3. That is the work energy equation, which we have used as case 4. Remember, that was case number 4. Let me remove the case. That is simply this statement: work done by external force or engine, that is equals to change in kinetic energy plus change in potential energy plus work done against resistance. They have given us the work done against resistance, that is 0.5 joules. First of all, let's calculate each one separately. So if I calculate each one separately, let me choose 3 colors and this bluish. Okay, so there's greenish. The first thing, that is the change in kinetic energy, that is equal to half into m into 0.6 square, that is the final minus initial 0 square. Second thing, that is the change in potential energy. So therefore, the change in potential energy, that is equals to m and g, and cosine, actually sine, 45 degrees into distance along the plane, that is 1.0 meter. So this is mg sine theta into distance along the plane. And what else is there? What else is there? We have the work done against resistance, that's already given. Work done against resistance, that is given as 0.5 joules. So as such, this and this and this is not needed. Maybe they could have asked for F max. So F max is F max multiplied by this distance is equals to this thing. The value of F max is 0.5, and then they can ask for coefficient of friction, which they haven't. And what else is there? Let me choose another color. So therefore, let me choose this purple. That is work done by external force. This external force is tension, because tension is the one pulling it, multiplied by distance, that is 1.0. Now, when I have all this thing, let me just take it to the side. And work done by external force, look at the working. This you have a change in kinetic, that is the green one. Change in potential, that is the pink one. Work done against resistance, that is the blue one. So this is all done, everything is in place. We have this thing, this equals to this plus this plus this. Change in kinetic is also positive because the speed increases, and change in potential is also positive because it's rising up. So you take care of everything, you add it all up, and then you would solve and you will find the value of m. So that is the working for this part. Just to give you an idea, there were 3 methods in which the examiner has worked this out. This is the first method. This is the second method, and what I have done is that I have applied this third method. Kinetic energy and potential energy for particle m, this they have evaluated it earlier. My steps is basically something like this. This is my step 1. So let me label it. This is my step 1. This is that my step 2, which gives me this. And then applying that equation, so therefore this one, kinetic energy potential for m, the whole equation is applied. This is work done against resistance, and that is the answer that we get. So we have done February, March 2021 M1 paper. Stay tuned for more papers. Take care.